Alright, so if I asked you to evaluate this, we could do the sums, or we could recognize the limit of the sum is the same thing as a what? Well, it is a summation.
Oh wait, no, that's not
The integral. So we could change this into an integral. From where to where?
1 to n.
0.
1 to infinity.
1 to 0.
Oh, 0 to 1. Sorry, I was looking at the wrong thing.
Okay, because we have that integral, so it's an integral from 0 to 1. Okay, now I need to figure out my function. So think about this. We had to have a change in x. What's our change in x? No. The change in x is 1 over n.
Wait, the y? Oh, I wasn't looking. Okay.
Your x sub I would have been 0 plus 1 over n I, right? Or 1 over n I. Okay, so we are trying to work backwards. We know the change in x gets turned into a dx, right? Before we were taking integrals and writing them as sums. Now we're trying to go the other way. So my change in x, my 1 over n, is a dx. So if I need to think about this, I had 2i over n squared.
2i n.
So that's like 2 times an I over n times a 1 over n. Would you guys agree with that?
Yeah.
So we have 2. I over n is 1 over n. That was my x sub I, so we turn back into an x. 1 over n is my change in x, so that is my dx.
Wowza.
Hang on.
So-
Can you slow it down? I don't understand.
What is the sorcery?
So, the handout we turned in yesterday. At the end of it, we evaluated all those integrals by changing them into sums, right? And when we did that, we said, okay,
Oh yeah, I understand.
we had to find our change in x and our x sub I.
Mhm.
And when we had the integral, we had our starting and ending points. So this one started at 0, ended at 1. And we had f of x dx, right? And the dx got replaced with change in x. So if we're going backwards, my change in x would go back into a dx. My change in x is 1 over n. So I was trying to figure out, I had 2i over n squared. I need to figure out, what do I have when I take out my x and my dx from there? My change in x is 1 over n. So I separated out a 1 over n from that. Okay, that left me a 2i over n. Okay, but I know I over n is my x sub I, so that's like a 2 times I over n times 1 over n. The x sub I will turn back into an x. So we have a 2, we have an x. The 1 over n goes back to my dx. So I'm asking you to evaluate the interval from 0 to 1 of 2x dx. So what's the antiderivative of 2x?
X to the 1, x squared.
From 0 to 1. So we get 1 squared minus 0 squared, or 1. So just know before we knew how to do integrals the fast way, we would take an integral and write it using the limit of the sums of all that. We can also start with the limit of the sums and turn it into an integral. That's what we did right here.
So you want that far?
Yeah, that's good notation to get into, just to remind you to plug in numbers, because we will eventually do these without numbers to plug in, so we need to have that.
Oh, without numbers.
I mean, you already have, you've done antiderivatives, we just didn't write them as an integral. I just told you to do the antiderivative. Okay. Let's look at this one. If I asked you to evaluate this,
Change it to a summation.
okay. So this is the limit as n approaches infinity. Okay, how would I write this? The sum from 1 to n. But then I
I
need
to
to,
the fifth.
N to the I to the 5th
with this? We agree with that? The denominators aren't changing, right? Okay. But I'm hoping that I can use an integral to do this. So we need to work backwards. Let's figure out what our change in x and our x sub I are. What's my change in x?
1 over n.
1 minus 0 over n is 1 over n. What's my x sub I?
1 over n I.
Okay. So I want to separate out a 1 over n because that's my change in x, and I know when I write my integral that has to get turned into a dx. Okay, so I'm going to pull one of those n's out. When I'm doing this, do I need I have a 3 on the denominator. Do I need that? No, so let's just kind of keep that in front. 1/3. If I take out that 1/3 and I take out one of the n's, what I'm left with, I over n
I
to the 5th. Okay, you could write it as I to the 5th over n to the 5th as well. But what is I over n?
x.
So that's going to turn into my x. My 1 over n is my dx. So we have the integral. We were again on 0 to 1. 1/3 x to the 5th dx. So can we do the antiderivative of that? Add 1 to your power. So you need a 1/6 in front times our 1/3. 0 to 1. I'm going to pull my 1/18 out, so then I have 1/6 minus 0 is 6. You get 1 over 18 times 1. Or 1 over 18.
Yeah, I think they're nice. I think if you asked me to do basic algebra right now, I would
That'd be
able
too
to.
much.
Yeah.
Any questions on that one? Okay, so these are just a few things with integrals. Just like with limits and everything else, if you have a constant, you can pull it out front, and I've really been doing this when we evaluated some of our integrals anyway. Constant multiples, again, those can come out in front. Some, if you have things added together, you can do individual integrals and add them. So the properties, there's nothing earth-shattering here, it's just what you would expect, okay, as we go through these. The other thing that is sometimes helpful is you can break up your integral. If you have some number between a and b, you could break it into chunks and integrate starting at a to a point, and then from that point to b. So for instance, if I were wanting to integrate from like -4 to 7 of some function, it might be helpful for me to integrate from -4 to 0, and then from 0 to 7, and add those together. That is usually like when you have a piecewise function. When it's defined differently on different parts of the domain, you'll have to do an integral for each piece.
You mean like the next one here?
That's convenient.
Oh, no, I don't really like piecewise functions.
Alright.
Oh,
Let's take a look at this one.
wowza.
So if I asked you find the integral from -1 to 3 of 2 absolute value of x dx. Anytime we have an absolute value, what do I make you do?
Piecewise function.
Yep, we rewrite it as a piecewise every single time. So if I did that, we know the value of x is just x if x is greater than or equal to 0, and the opposite of x if x is less than 0. So I would need to break this integral up and go from -1 to 0, and then from 0 to 3. From -1 to 0, you're putting in negatives. So the absolute value of x becomes the opposite of x. Yep. Times 2, so we could say -2x dx. But from 0 to 3, you're putting in positives, so the absolute value doesn't change anything. So it's just 2x dx. Alright, so from there, antiderivative. What's the antiderivative of -2x?
Negative x.
-1 to 0. And the antiderivative of 2x?
X.
X squared from 0 to 3. Okay, so the first one.
Wait, x squared. Oh.
So I have the opposite of 0 squared minus the opposite of -1 squared. So I get 0 plus 1. Over here, 3 squared minus 0 squared. 9 minus 0.
I like that you don't even have to see outside of the rain.
I know, that's what I was just
Because
thinking.
the birds start.
That's exciting. Come in. Is that okay? Let's do. I don't know if I
Let's
would
do
like
something a little harder.
What?
I'm the last page.
Oh.
No, I'm cooked.
Whoa.
What does the line mean?
Oh, we're doing this by ourselves?
It's an absolute value.
Yeah.
Where's the other bar though? Oh, it's x plus 2.
So where are you going to have to separate this one?
I thought x plus 2.
0 and 4.
Oh, sorry. It's 3 times the absolute value of x plus 2. So when you do your piecewise, okay, where's the breaking point? What x value?
Just -2.
-2. It's what makes the inside 0. So if x is greater than or equal to -2, if x is less than -2. If you put in something bigger than -2, this is positive, the absolute value does nothing. If you do something smaller than -2, it's the opposite. So it would be,
Negative x minus 2.
why don't you guys try it? We're going to have to integrate from -3 to -2. And from -2 to 4. The 3, you can keep it in. You could also, if you want, pull it out in front of those integrals. That is one of the properties. So if you kept the 3 inside, that's fine. If you don't want it there, you can pull it out in front. It won't matter. You'll get the same answer. If I'm putting in something between -3 and 2, that means that x is less than -2, so I'm getting the opposite of this, so -x minus 2 dx. If I'm putting in something between -2 and 4, that's a positive, so we're just getting x plus 2 dx. So the antiderivative. What's the antiderivative of -x?
Negative 3 halves x squared.
Negative, oh, you went ahead with it.
Yeah, sorry.
With it. That's totally fine. Minus antiderivative of 2 would be 2x. Over here, 1/2 x squared plus 2x. Or you could have had your 3 multiplied through. -2 to 4. Alright, so if I plug in my -2, -2 plus 4, so 2 minus, -3, -9 halves, plus 6 is 3 halves. Are you guys checking my math? Does that sound right?
Yes.
Thank you.
Sorry, I like mine's different, but yes.
Yeah. If I put in my 4, 16 times that is 8. 16 minus 2. Do I have a mistake?
I don't know, I ended up with 31 and a half as my ending thing, so.
So let's